Hello, everyone. Today I'll be doing this project, Hospital Analytics, which is a guided project provided by Maven Analytics. And in here, we'll be analyzing hospital patient encounters, costs, and behavior trends. I have gone ahead and downloaded the data and loaded it into my SQL Workbench. And this is the data dictionary that was provided to us. So it has 5 different tables: encounters, organizations, patients, pairs, and procedures. And this gives us a good idea of what the tables are, what fields they contain, and the description about them. So I've also gone ahead and put this document together. These are objectives and questions taken directly from Maven Analytics. I've just put them here together so that I can find them all in one place and it's easy for me to copy and paste them. So I think I'll jump directly into it and we can look at us the tables as we do the questions. But the first one, as it says, is about encounters overview. So we'll probably be dealing with that table. So we see that it has an encounter ID, which is the primary key, the start and stop times for the encounters, the date and time, which is so it's a timestamp, the patient foreign key, organization, and so on. So we'll take a look at these more when we do the questions. Encounter in this case means a recorded interaction between a patient and a hospital or a healthcare provider for the purpose of care or any service that they're seeking, right? So let's get ahead with the first question. I'll just copy this and I'll paste it on top here while doing the question so that we can keep a track of what question we are solving. So this is the first question. So this is objective one, question one. So I'm going to put a 1.1 here. So I think they're starting off easy with how many total encounters occurred each year. So what we can do is we can load the table here and see that how many total encounters occurred each year. So we'll need the timestamp column start, right? So there might be some encounters where the encounter started in one year but like stopped in the next year, but it'll still be counted towards year in the start column here, right? So we'll start with this query here. Should be pretty straightforward. We are extracting the year from the start column, and I'm just going to call it my year, and we do a count star as total encounters from encounters, and then we need to group this by the column my year, and I'll also order by it in ascending. So let's run that query. So this was pretty straightforward. We have years here and then total encounters in each of those years. So that's our first question. We'll move on to the second one. I'll copy it first and then we'll read what it is. So we have 1.2. I'll zoom in and also have the word wrap on. Okay, so for each year, what percentage of all encounters belonged to each encounter class? And we have these different encounter classes here. I hope that's all of the different encounter classes that we have, but we can check that. Distinct. I'm just going to check the name of the column. Columns. So it's called encounter class. Okay. Okay, that gives us all the different encounter classes: ambulatory, outpatient, wellness. Okay, it's the same over here. So what we're trying to do is percentage of all encounters that belong to each encounter class. So first, there's two things that we need. We need the years, and then we need the number of encounters in each of those classes, and then we need to divide that by the total number of encounters to get the percentage. So basically, it will be something like this, where we have years as the rows and the encounter classes as the columns. So it will be a pivot table style output. So and then the values will be the number of encounters in that particular year and encounter class. So let's start to do that. I'll take that off. So I think we should start with one of the encounter classes and see build out our output. and then expand it to get all the encounter classes. Let me show you what I mean here. So we needed the ears. So here we have the ears. And now what we need to do is go through each of the rows in the table here. Let's do a select star again. Select star. Okay, so what we need to do here is go row by row and see if the encounter class is, let's say, ambulatory. We'll start with that. If it's ambulatory, we put a 1 there. We extract the ear, and then we check if the encounter class is ambulatory. If yes, we want that to be a 1. And at the end, we'll sum all of the ones to find out how many there are in each ear and encounter class. So for that, we will need a case statement here. So it will look something like this. So we say case when encounter class, get rid of that, equals ambulatory. Then we want 1, else we want a 0, and then we end the case clause with the end keyword. So this is what it will do. Just like I said, we want it to be 1 when the encounter class is ambulatory, else 0, and then at the end we want to sum all of it. Right, so I'm gonna call it ambulatory just because that's the name of the encounter class, and then we'll need to group it by ear. So I'm gonna do group by, I'll just copy and paste it here, and then also order it by the same thing. Okay, let's run it. Okay, so seems like we've got what we wanted for the first encounter class, ambulatory. So we have all the years and we have the number of encounters which were ambulatory. So all we have to do is basically replicate this statement for each of the encounter classes here. So I'm going to do just that, and we'll change the class name in each of these statements. Duplicate, we've done outpatient. Now we need wellness. Is wellness. Oh, and we also need commas in each of these. Duplicate, urgent care. I'm guessing that would be one word. That's how it would be stored, hopefully. If not, I'll come change it later. So that's urgent care. Then we have emergency. And the last one we have is inpatient. We don't need a comma at the end there. So let's run that. And there we are. So we have the number of encounters in each of these classes and years, but what we need is the percentage. So what we need to do to each of these numbers is divide by the total number of encounters that happened, like that are in the table. So for that, we'll need to divide it by count star, right? So all the records in this table. And since it's going to be a percentage, we need to multiply it by 100. And I'm also going to round that percentage to 2 decimal places. Yeah, 2 is fine. So we'll need to do that for each of these lines here. So let me just copy paste them everywhere. It's a little manual, but hope this works. This should be it. So I'll run this query. And there we go. So we have our percentages. So in the year 2012, 42.5% of the encounters were ambulatory and so on. So that's our second question. And I'll move on to the third one. Copy and then paste and zoom in. Okay. So what percentage of encounters were over 24 hours versus under 24 hours? Okay, so let's start from encounters. I just like to check the table a lot. Gives me some visual hints. So here we want the duration of the encounter, right? So that's start and stop columns right here. So we want to find the difference of the start and stop columns. Now these are timestamps, date and time. So we need the difference of these timestamps in hours, and then we check if it is over 24 hours or under, and then we divide them by the total number of encounters to convert that into a percentage. So let's start with the extracting the difference first. I think there's a function called timestamp diff. Time diff. Oh, there's a timestamp diff here, right? And this one, it takes the unit first in which you are trying to calculate the difference, the time difference, and then the start column and the stop column. Just gonna call this length. Okay, so this will give us, actually what we can do is we can check if it is giving us the correct answer or not. So we can just run this for now to see if we get the correct timestamp difference. So this one is 9:46 and 10:01. So yeah, that's not 1 hour. We're trying to look at records where it's at least 1 hour. So like this one, 6:19 and 7:19. So that's 1 hour. 21st, 16:19 and 18:49. That's over an hour for sure. 16:19. So 4:20 and 6. Yeah, that's 2 hours. Okay, perfect. So we've got our time difference in hours here. So what we need to do here is check for each of these rows if that length, that the time difference is above or below 24 hours. So I'm assuming that over 24 hours means like greater than or equal to 24 hours. So for each of these rows, we'll have to do the same thing, use a case statement and find out if it's over 24 or under, and then sum them at the end, and then divided by the total number of encounters to find percentages. So I'm going to take that off and wrap this inside a case statement. So this will be case when timestamp diff is greater than or equal to 24. Then we want it to be a 1, else 0, and then, oopsie, then oh, end. And then we want to sum it, right, as length. So I'm going to change this name to over 24 hours, comma, duplicate. Then I'll do the same thing for under 24 hours. So change this to less than 24. And since we're summing, we'll also need to divide it at the end by the total number of encounters. And we'll have to do the rounding thing as well. So I might just as well do that. Round it, and we'll need to divide it by count star first, multiply it by 100, and then round it to 2 decimal places. I actually should have duplicated that, but anyway. Copy and paste. And then we're looking at all that. Copy and paste. Okay, and then think that should be it. I hope I got my brackets right. Okay, I'll run this. Perfect. So we have over 24 hours, 4.13 percentage of encounters were over 24 hours, and a big chunk, the majority of them were under 24 hours. So that's objective one, right? So let's move on to objective two here now. Cost and coverage insights. So it says your next objective is to analyze payer coverage, top procedures by frequency and cost, and average claim costs by payer. Okay, interesting. I'll just take that question here and then paste it. Call it 2.1. Okay. So seems like we're talking about the table encounters, still encounters. Okay. So select star from encounters. How many encounters had zero pair coverage? Let's see if there's a column like that. It probably is pair coverage. Yeah, so that's a column. So we see 0, 0.0, 0.0 over there. And what percentage of total encounters does this represent? So that also seems pretty straightforward and can be done with the case statement like we have been doing so far. So in this question, I'll just do it directly. So we see pair coverage is pair underscore coverage equals 0.00, then 1 else 0. And then we want to sum this, right? And then we are finding percentage. So we'll do count star again and then multiply by 100 for percentage. And then I'll also round it to two decimal places. So I'll add a round function over here as 0 coverage percentage. There we go. So we also need how many encounters. So not just percentage, we also need the number. So if we don't divide it by count star, that is the number of total encounters, we should get the number. So I'll call this 0%, 0 pair coverage. I don't know what to call it. I'll just say 0 pair coverage count. Let's run this. Oh, I made some mistake. And okay, the end keyword is missing from my statements here. I'll add both of those. Now run it again. Okay, so here we have the number 13586. So the count of encounters with 0 pair coverage was 13,586, and the percentage, it represents 48.71% of the total encounters. Okay, I just noticed that. So okay, that was question 2.1. So let's move on to 2.2. Okay, what are the top 10 most frequent procedures performed and the average base cost for each? Okay, so it seems like we're talking about the procedures table now. Okay, let's check the columns in that. So we have start and stop, but we're looking for most frequent procedures. Okay, let me just look at the table here from procedures. Okay, so for procedures, we have encounter code. Okay, so we have a code which probably is procedure code. It's distinct procedure code. Yeah, it's procedure code. Okay, so that should be distinct, but we also have the procedure name, which I like more so that we're able to see what the actual procedure was rather than looking at a code. So what I'll do is, so I'll take the description, since that's what shows what the actual procedure was. And we're looking at, we are trying to find the top 10 most frequent procedures. So seems like we just do a simple count and group by. So if I do count star as procedure count, and then we're looking at what average base cost. We want to find average base cost as well. So average, what's the column called? Base cost. Base cost as average base cost. So I'm guessing it will need rounding as well since it's an average, to two decimal places from procedures, and then we need to group it by description. And by description, I mean the procedure itself. We can do it by code as well, but I want it to be a little more descriptive. And since we want to find top 10 frequent procedures, I'll have to order it descending by the count, right? So that's how we'll get the frequent procedures. And then we want top 10 only. So I'll use the limit statement or limit function here and then run this. And we should have what we're looking for. So the top 10 most frequent procedures are these ones in descending order of the counts and the average base cost associated with them. Seems like a lot of them have very similar base cost, and the procedure count doesn't vary as much as well. 4,596, 4,098. Okay, good. Assessment of health and social care needs seems to be at the top, the most frequent one. Okay, well, that was 2.2. Let's move on to 2.3. Copy 2.3. Okay, and then perfect. So, what are the top 10 procedures with the highest average base cost and the number of times they were performed? So, that seems very much like the previous question, just this one said top 10 frequent procedures and the base cost associated with them. This one is just top 10 procedures by average base cost and number of times they were performed. So, seems like it'll be a similar query. So, I'll just copy and paste this one and then we'll make the changes that we need. So, we want the ordering to be by the average base cost first. So the highest one needs to be on the top. So instead of doing it by procedure count, we need to do it by base cost and the number of times. So number of times are being calculated here. It's just that I think this needs to be calculated after we find the base cost. It looks better in the result. I think that's it. So let's run that. Okay, so we see that the procedures that we see here are now different because they are based uh, in descending order of average base cost. So we see that admit to ICU procedure has the highest average base cost. It's 200 over 200 grand, and the procedure count is here as well. So seems like we just had to make that one change order by, but see one order by can change the result totally. Okay, so that was 2.3. I think we have one more question in this objective. 2.4. So wrapping. Okay. And then the question is, what is the average total claim cost for encounters broken down by pair? So total claim cost is in encounters by pair. So seems like we're looking at a join of two tables. And what we're going to be joining on is this pair, foreign key to the pair. Then here we have ID, this one. So pairs ID and encounters pair. Okay. So let's join those first and then we'll proceed from there. So let me just select nothing. I'm just going to do the from clause first here since we're doing a join. So we need encounters. I'm going to call it E. Left join pairs P on E dot. I think it was pair. The name of the column was pair, I think. Equals P dot ID. Was it pair? Let me double check. Yeah, pair. Okay. So we have joined the tables and we need average total claim cost. So we can just say average. The name of the column is total claim cost. Okay. Total claim cost. I'll just call it that, average total claim cost. Broken down by pair. So we need to group it by pairs. So P dot, what's the name in the pairs table? Let's check the columns name. Okay. P dot name. And we'll need to group by name as well since we're breaking this down by pairs. So group by P dot name and order by, let me order it by the claim cost in descending order. Perfect. Let's run this query. And there we have it. Okay, Medicaid had the highest average total claim cost, and then no insurance, and so on. Wow, no insurance is second highest. Okay, so that's the output for 2.4, and that's our second objective complete. Okay, now we move on to objective 3, which is patient behavior analysis. So our final objective is to analyze patient behavior by tracking quarterly admissions, and 30-day readmissions. Okay, so let's take that question. Zoom in, word wrap, 3.1. Okay, okay. And then how many unique patients were admitted each quarter over time? So quarter over time, which means we need quarter and year for each of the years, and then we need to count the distinct patients in each of those time frames. So this is probably still from the encounters table. So select star from encounters. So what we need to find out here is year and quarter both, and it will be better if we can like club them together somehow. So let's see, year start as my year, and then there's quarter, and say quarter, rt start. Okay, so this gives me years and quarters, and this I just have it here so that we can check if it's correct or not. 2011, this is August, so definitely third quarter. Okay, we can probably club these two columns together. That will be better visually. So what I'll do is, well, there's two ways to do it actually. We can multiply the year by 100 and add the quarter, or we can convert it to text. Maybe text will be better. So let me club it that way. So I'll use a concat to do that. And I'll have to cast the year as character. And then for concat, I need a dash. And then again, I'll need to cast this part here as character. Copy and paste as char. Close that parentheses there. Close all of that. My year. Let me just see what that gives me. Okay, that is perfect. Maybe also order by. Order by. This is not just my year anymore. It's year, quarter, quarter. Okay. Okay. So right now, yeah, it's doing it for each row. That's why I get so many duplicates. But it's the correct order that I want it in. The only thing left to do is count unique patients. So to count unique, we need a count distinct and patient. I think patient was the foreign key to the patients table. So I'll just use that column as unique patients. And we need a group by year quarter. Group by year quarter, and I'll run this query. And perfect. So we have unique patients each quarter over time. Yeah. So each quarter over time, the number of unique patients. Okay. So that's question 3.1. Move on to 3.2. New SQL file. 3.2. Zoom in. Okay. How many patients were readmitted within 30 days of a previous encounter? Okay, readmitted. So for readmissions, we are still in the encounters table. Select star from encounters. We look at the table to see how we can solve this within 30 days. So for 30 days, we'll need start and stop, and we'll need each patient's next start time as well. So for that, each patient, which means this column here, patient. So let's see how we can build it out. So we know that we want it for each patient. That's how we can count them. And then we need the start and the stop columns. So what we also need is, so we know, let's say this patient here, this is his, let's say, first encounter. He started at this time, stopped at this time. We need another column here, which will tell us the start time for the next encounter, right? So what we'll do is we'll subtract the start time from the next encounter with this stop time from the first encounter, and then find if it is within 30 days. If yes, then we'll count it, and that should give us what the question is asking for. So we can do it two ways, either lead or lag window function. But if we do a lag, which means we'll go back to the previous rows, which don't really exist. So we'll either lead or lag by one. So I'm inclined to use lead here because what it will do is whenever this patient's actually, let me show you what I mean from encounters where patient equals, not sure if this is a character, a string or not. Is it just that? Probably not. Not sure how to extract that yet. Patient in patient here, foreign key. Oh, it doesn't tell me what data type it is. Anyway, so what we're trying to do is, yeah, just that. So for each patient, what we'll do, so for this patient, we want start and stop, and we want the start time of the next encounter, which we can fetch using the lead function and lead it by one row. And yeah, go from there, find the 30 days readmission time. So what I'll need to add here is the lead function. Lead, we are going to lead the start column because we need the start time for the next visit, the lead start, and we're going to do this for each of the patients. So we'll do partition by patient, and we're going to do it in ascending order of the start column. So ascending, so I'll just write that out as well. By default it is ascending, but writing it out makes it a lot more clearer. And let me call this next admission. Okay, and let's do that, and you'll probably see what I mean here. So see, this is the first encounter on 22nd, and the next encounter was on the 19th of the next month. So we wanted this start date for the second encounter next to the stop date of the first encounter. Now all we need to do is find the difference between these two and see if it is within 30 or not. So we'll do it for each of the rows for each of the patients, and there might be some rows where it'll be less than 30, right? And we'll need to count all of those. So since we cannot, in the where clause, we cannot use the window function, so we'll put this in a CTE. We'll have to put this in a CTE, and so select, we'll come to the select afterwards. What, let's write out the rest of the query from. So we're looking at where we want the difference of these two to be less than 30. So we'll use the date diff function, and we just give the name of the columns that we're trying to subtract from each other. So next admission is going to be the higher value, or the more later date, and stop, and this we don't need alias, we just need to check if it is under 30 or not. And from all of those rows where there is a readmission within 30 days, what we need to do is find how many patients, so which means unique patients. So we'll do a count distinct here, count distinct patient as, just call readmissions, and that seems right. I'll run this query, and yeah, there we had this squiggly line over here which tells us there was some problem with CTE as, my bad. Okay, now we can run this. Okay, 771 readmissions. So that is our answer. We had 771 readmissions. Perfect. We'll move on to the next question, 3.3. Copy. 3.3. Which patients had the most readmissions? So now we're trying to find which ones had most readmissions. So it's the same table encounters. So for which we'll have to look at patients. Okay, so this is the encounter ID, this is the patient ID. So we'll need to find distinct patients and most readmissions. So the readmissions are going to be found the same way like we did in our previous question. So I'll copy paste that CTE here. Okay, and patient, start, stop, lead. All of this remains the same. From this, what we need to do is from CTE, we do the same thing. We need that dative thingy. So copy and paste. And so we need it by each patient because we need to find which patients. So we need to use the patient ID, this one here. So we'll do select patient and we need to do a count star as readmission count. So we have the patient name, we have their readmission count. We need to group this as well. Make this smaller so that you can see the entire query together. Okay, so we need to group this by patient and also order by maybe readmission count descending. Okay, let's run that query and there we go. So these are the patients which have had the most readmissions. So this patient seems to be the favorite. Sorry, the hospital has this patient as their favorite. So most readmissions 1376. So these are the patients. So if we need to find the name of the patients, we can do that using the patients column where we can find or extract their first and last names. If we need the full name, we can do a concatenation. And perfect. It was fun doing this project. I think that's all the questions we have. Uh, Thank you everyone for watching this.